Hello friends and welcome. In this video we'll look into factors and multiples. We'll see how to find HCF and LCM and solve some practical problems on them, and we'll also see how to find prime factorization. So let's get started. So what are factors? We say that a factor of a number is an exact divisor of that number. So when a factor divides the number, it leaves no remainder. For example, to find the factors of 36, we start by dividing 36 by 1, then by 2, and then go on. And we stop when the quotient is equal to the divisor. Because the next divisor would have been 9 and we would have got quotient as 4. After 9 it would have been 12 and we would have got quotient as 3. After 12 it would have been 18 and then 36. So no need to write it again here. We can stop here. So we say that the factors of 36 would be these divisors and these quotients. Right? It would be 1, 2, 3, 4, 6, 9, 12, 18, 36. These. Now let's take another example. To find the factors of 99. Again we'll start by dividing 99 by 1 and then the next factor and then the next factor. And the next factor after 9 would be 11, which is already here. So we again stop when the quotient is the next divisor. Therefore the factors of 99 would be 1, 3, 9, 11, 33, 99. So we have taken an even number and an odd number. Let's take a prime number. For example, 37. So prime numbers are the numbers which can be divided only by 1 and the number itself. So the factors of 37 would be only 1 and the number itself, 37. So now between these three numbers, what is the common factors between these three numbers? It would be 1. And if we had to find the common factors between 36 and 99, it would be 1, 3 and 9 because they appear in both set of factors. And what is the greatest among these common factors? It is 9. So the HCF or the highest common factors or the GCD, the greatest common factor between 36 and 99 would be 9. So this is how we find factors, and this is one of the ways how we can find HCF. Now let's look at some interesting facts about factors. 1 is the factor of every number. Yes, obviously 1 divides all the number. Every number is a factor of itself. That is also very obvious. Every factor of a number is an exact divisor of the number. Yes, that is from the definition because the remainder should be 0. Every factor is less than or equal to the given number. The number was 36 and all the factors are less than or equal to the given number. The number of factors of a given number are finite. Yes, the factors will be finite set of factors. So you should keep these facts in mind. Now we'll move to multiples. So multiples are nothing but the product tables of number. For example, to find the multiples of 6, 9 and 12, we just write the product table of these numbers, and these are the multiples of 6, these are the multiples of 9, these are the multiples of 12. So we can see that we can go on multiplying and find the multiples of these numbers. So the multiples are infinite. Now the common multiples between these three numbers are 36 and 72, and there would be many more as the multiples can go till infinity. And what is the least among these common multiples? It will be 36. So the LCM of these three numbers is 36. Similarly, the common factors between 6 and 9 will be 18, 36, 54, 72 and many more as we can go on finding multiples till infinity. And the least or the smallest number from this set is 18. So the LCM between 6 and 9 would be 18. Now let's take a look at some interesting facts about multiples. Every multiple of a number is greater than or equal to number. Yes, all the multiples are greater than or equal to this number. But for factors, all the factors were equal or less than the given number. The number of multiples of a given number is infinite. We can go on multiplying and we can have infinite set of multiples. And factors were finite. Every number is a multiple of itself. Yes, 6 is a multiple of itself, 9 is a multiple of itself, 12 is also a multiple of itself. Alright? So this is how we can find multiples and LCM. And now we'll look into prime factorization. When a number is expressed as product of its factor, then we say that the number has been factorized. For example, when we express 36 as the product of its factors, we say that 36 has been factorized. And when these factors are broken down into prime numbers, such factorization is called as prime factorization. For example, for 36, we'll break down this 18 into prime factors. So 18 can be written as 2 into 9. Now 9 can be further broken down as 3 into 3. Now here all the numbers are prime numbers, so we say that 36 has been prime factorized. So similarly, 48 can be prime factorized as 2 into 2 into 2 into 2 into 3. All the numbers are prime numbers. And 45 can be prime factorized as 3 into 3 into 5. So all the factors are prime numbers here. Now we'll use prime factorization method to find HCF and LCM. So we saw how to find HCF first here. We found out the factors of the number, then found out the common factors, and from the common factors we found out the highest number in that. So that was the HCF or the GCD. Now we'll see how to find the HCF using the prime factorization method. Now to find the HCF of 20, 28 and 40, we'll do the prime factorization of each of these numbers. So 20 will be expressed as 2 into 2 into 5, 28 will be expressed as 2 into 2 into 7, and 40 will be expressed as 2 into 2 into 2 into 5. Now after we have done this prime factorization, we'll only select the common factors in all of these three numbers, which is 2 times 2 here. The third 2 is not present in 28 and 20, so we'll remove this 2. 5 is not present in 28 and 7 is not present in 20 and 40. So we'll remove these and we'll get our HCF. So the HCF of these three numbers would be 2 into 2, which is 4. Now we'll see another method to find the prime factorization, and through that we'll find HCF. Now we'll take 20 and do the prime factorization like this. Again we'll start with the smallest prime number and divide 20 to get 10. 10 can again be divided by 2 to get 5. So the next prime number which can divide 5 would be 5 itself, so that we'll get 1. So we'll do this for 28 also, so that we'll get 2 into 2 into 7, and we'll stop when it is 1. So similarly for 40 it will be 2 into 2 into 2 into 5. We'll stop when we'll get 1. Now we'll only keep the factors which are common in all the three, like we did here. So we'll be left with 2 2's in each of them. So the HCF would be 2 into 2, which is 4. So this is how you can find HCF. Now we'll see how to find LCM. Now we first found out LCM here. We first wrote down the multiples of each of the numbers, and from there we found out the common multiples. And from the set of common multiples, we found out the smallest number, that is the LCM. Now we'll look into three methods to find LCM. The first method would be writing the multiples again, but in a smarter way. Now to find the LCM of 20, 25 and 30, we take the smallest two number, that is 20 and 25, and start writing the multiples of it. For example, for 20 it will be 20 into 1 it is 20, 20 into 2 40, then 60, then 80 and then 100. And for 25 it will be 25, 50, 75 and then 100. So we'll stop here because we found out a common multiple between these two numbers. Now we'll check if this multiple is also a multiple of the next number, that is 30 here. So we see that it is not. So we'll go into the next multiple. So the next common multiple would be a multiple of hundreds. We take the next multiple of 100, which is 200. Is 200 a multiple of 30? No. So we'll take the next multiple of 100, which is 300. So is 300 a multiple of 30? Yes. So the first common multiple between these three numbers will be the least common multiple. Hence the LCM of these three numbers is 300. And the next common multiple between these three numbers would be a multiple of 300, which will be 600, then 900, then 1200 and so on. So in the method 2, we'll see how to find the LCM of these numbers using the prime factorization method. We'll do the prime factorization of each of these numbers. So 20 will be 2 into 2 into 5. 25 would be 5 into 5, 30 would be 2 into 3 into 5. Now from this we'll see what are the unique factors. So the unique factors are 2, 3 and 5. And to find the LCM of these three numbers, we'll take the maximum occurrence of these unique factors. For example, the maximum occurrence of 2 is twice in 20. So we'll take 2 twice. The maximum occurrence of 3 is once. So we'll take 3 once. The maximum occurrence of 5 is twice in 25. So we'll take 5 twice. And we'll multiply these to get our LCM. So this is how you find LCM using prime factorization. In method 3, we'll use a graphical method. We'll take all the three numbers and start dividing it by the smallest prime number which can divide any of these numbers. So it will be 2. So when we divide 20 by 2, we'll get 10. 25 cannot be divided by 2, so we'll leave 25 as it is. 30 can be divided by 2, we'll get 15. Again, out of these numbers, 10 can be divided by 2 again, so we will divide this by 2 again, so we'll get 5. 25 cannot be divided by 2, so we'll leave 25 as it is, 15 as it is. The next prime number which can divide any of these numbers is 3. 3 can divide 15. So 3 can divide 15, so that we'll get 5. And 25 cannot be divided by 3, so we'll leave as it is and 5 as it is. So the next prime number which can divide any of these numbers is 5. And again 5 can divide 5, so that we'll have 1, 1, 1. So when we reach 1 for all the numbers, we'll stop. And then we'll take the product of these numbers, and that will be the LCM. So we saw how to find LCM using the 3 methods. Now we'll see how to solve some practical problems on LCM and HCF. Okay, so let's consider this example. We have 2 tankers, one containing 850 liters of kerosene and the other containing 680 liters of kerosene. We have to find the capacity of a container which can measure both these tankers in an exact number of times. So for example, if we assume the capacity of this container to be 100 liters, we can measure this tanker in 7 times. But in the 7th time, the container would be only 80 liters filled. That is not exact number of times. And if we measure this tanker, we can measure it in 9 times. But in the 9th time, this will only be 50 liters filled. So that is not exact number of times. So this has to divide both of these such that there is no remainder. Therefore, this should be a common factor between 850 and 680. And since we have to find the maximum capacity, this has to be the HCF of these 2 numbers. So by analyzing like this, we found out that this question is actually for finding the HCF of these 2 numbers. To find the HCF between these 2 numbers, we do the prime factorization of these numbers and take the common prime factors. So 2 is common once, 5 is common only once, and 17 is common only once. So it is 2 into 5 into 17, that is 170 liters. So the capacity of this container should be 170 liters. Now we'll see an example of practical problems of a LCM. So consider this example. In a morning walk, 3 persons step together. Their step measures are 80 cm, 85 cm and 90 cm respectively. So what is the minimum distance each should walk so that they can cover the same distance in complete steps? So when they walk 1 step, they cover 80, 85 and 90 cm respectively. So what about in 2 steps? They will be covering 160, 170 and 180 centimeters respectively. If they walk 3 steps, they will be walking 240, 255 and 270 centimeters respectively. So if you see the question, it is asked distance each should walk so that they cover the same distance. So this distance has to be same. Now if you observe this pattern, you can identify that this question is related to finding the LCM of these 3 numbers. So we find the LCM of these 2 numbers, we'll get the answer as 12,240 centimeters. So this was all about factors and multiples, common factors and common multiples, and HCF and LCM. Before you move ahead to the next tutorial, solve the questions that are provided for this tutorial. Until then, take care and study well.